Okay, this will be the shape of the rope. Okay, let's get into some part. This is very, very important. You don't have in textbook. So I'm trying to explain through the diagram. I think this was a problem, no? I have to redraw it. Let me redraw it again. It may give wrong information. Only this part. Okay, fine. Yeah. Okay, now we are in better position. Okay, now look at this. So this is at 1 instant of time. This is at t equals 0, you better see. After some time, or this is t equal to 0. After some time, t equal to t by 4. The wave is propagating in this direction. Okay, now I'm interested in these segments. Let me go for segment. Small elemental segment. Let me pick up. In fact, than blackboard, no, I do have colors. Very easy to really show this one. So this particular segment is what I picked up. Just an infinitesimal element is what I picked up here. Blue, we'll take the blue. Try to concentrate on these elements. Okay, now, now look at this. Let's come for this one. So this element, what will be the direction of its motion? I think according to the this one, what we know, they should be moving up, velocity of that particular point. So it will be moving up. And what is the state of this element? All of you, are you looking at this one? What is the speed of this particular point? Will be zero. Then, so what is the kinetic energy of this element? This should also be zero. Okay, agree this. So, and what is the slope here? Slope is also zero. So therefore, what will be the potential energy? Potential energy also will be zero. So like that. So for when you look at these elements, no. So these quantities, what will happen? So those which are indicating with red color, they're at extreme position. So because of that, what will happen? What is the kinetic energy will be zero. What is the potential energy will be zero. Sir, how you can say potential energy? I'm just comparing with the elements here now. So I'll compare. So the element what I picked up is this one. Oh, so sorry. I had to give color. No, the three elements will pick up. I think I'm trying to explain. Three will take one more. Okay, fine. So for these are the four elements what we have picked up. Yeah. Okay, you have all the colors. So what are this element 1, 2, 3, 4? Like this will give number. What is the length now? So when there is no wave propagation on a string, so what is the length of all these elements will be same. So let me take that to be delta L or DL or dx, 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 and dx. So what is the length of all these elements will be same. May not appear through diagram, but in fact all the length are to be will be same that one. So what is the length of all these elements is equal to this one. So let me write dx4, dx3, dx2, dx1. So in fact, dx equal to dx1. Initially, all identical elements I have picked up. Okay, now when the wave propagates, so look at the element 1. So what will be its elongation? I think it's going to be same. What was the elongation? Also is going to be same. I'll putting boundaries so that it'll be easy for you. Any reason for that? Because no elongation, no, it is exactly at extreme point. What is the elongation? There won't be any elongation, and what is the state of it will be at rest. So look at the element 1, no elongation. Sir, how you can say no elongation? What is the length of this element? The same length will be there. This particular point 1 is at extreme point. At extreme point, there won't be any elongation. No, come for element 2. It is having a speed, no? Because the one which is at mean position will have maximum speed. Then compare the elongation. So definitely what happened, its elongation will be more. Now, this is very, very important. Please do notice. So why you are increasing length? Why you are increasing length? It's a simple idea. So if you have a rope like this, and if you have like this, tell me like what will happen to the length? Please, it's all about the geometry is what you can look at this one. Look at this element 2. When there's no wave propagation, it will be like this, no, horizontal. When the wave propagates, what will happen? The same element 2, it will be at, say, at some instant of time will be at mean position. And what happened to length? Length will be more, will increase. Agree this one? So shall I say that it is having elongation? And since elongation is there, there should be potential energy. And also there will be kinetic energy. Hmm? There will be also kinetic energy. Now compare this element, green color one. It is at, again, extreme point. So what is the length of this? Will not change. Then what is the state? It will be a test. Let's compare the pink color element. So what do we expect? The length will be more when it is at mean position, and also it will have kinetic. In what direction it will be moving? It will be moving in vertically downward direction. Okay, no, sir. Finally, sir, okay, what you want to conclude? You can ask, a student can ask. So here what's happening is like, at this instant at t equals 0, the kinetic energy of the element 1 will be 0 and the potential will be 0. Sir, how you can say? So you can look at this one. Element 2, what is the length of this? Say dx. So when the wave propagates, what pen, its length will be more. So let me write here. So this is dx2, what we assume, no? So this will be dx2 dash. Dx2 dash will be greater than dx2. What about dx1? Dx1 will be same as it is. And in fact, what will be the dx1? Dx1 will be like, I'll show only for, okay, this is dx1. So what about the length? Length will be same. Here length will be. So now, so we know that if a particular element, if it is having length more than its initial length, shall I say it is being elongated, it is being stretched. Stretched means it must have elastic potential energy. Got the idea? This one. So now tell me, like, if a wave propagates, where kinetic energy will be maximum? Shall I say at mean position? Where potential energy will maximum? At mean position only. So when a wave propagates, where kinetic energy will be maximum? At mean position. Where potential energy maximum will be at mean position. There's a fine conclusion. Sir, what about the extreme point? Both potential and kinetic will be zero. Both potential as kinetic will be zero. What about other points between the mean as well as extreme? Both potential energy and kinetic energy will be non-zero, but it will not be maximum. It will vary between the minimum and maximum. So therefore, if I move from extreme to mean position, what will happen to the kinetic energy of the different elements will increase. Sir, how you can say that here only kinetic energy maximum? I think I have the set of formulas. Why there is? Are you seeing the screen visible? Huh?
Yes, sir.
So my mouse is not moving. Now it's visible, huh? Everything?
Yes, sir.
Okay, then we'll continue. So as I move from extreme to mean, so what will happen to the potential energy? Should increase, will I agree? And what happened to kinetic energy? Will increase. So now you can ask questions, sir. How do you can say very clearly? Okay, let me go for this formula. Vp equal to minus V into slope. Substitute wave speed and this with a this one like a with sign. Okay, now let's come for this one. What is the slope of this? Will be zero. If slope zero, speed will be zero. So this element will be a test. Then what is the potential energy? Potential energy depends upon elongation, we know. So the element which is at mean position will have more elongation. So therefore now, so and as I move, what will happen? The elongation decreases. So therefore, if I move from mean to extreme, potential energy and kinetic energy both will increase. From extreme to mean, if I move, both potential energy and kinetic energy will increase. Then when I move from when I move from mean to extreme, what will happen to potential energy? Will decrease because the slope will decrease. Then kinetic energy, it also decreases. Okay, there's a one basic idea. So therefore, I'll put one. If you look at the books, no, so they have brought one. A very simplified diagram is available in book. So when a wave propagates on a rope, any direction, let me take towards right. Then where kinetic energy will be maximum, here kinetic energy will be maximum. I think in books you have this much of diagram. I think it is enough. Actually, it is enough, and it's not a graph; it's a string itself. I'll making things clear. Okay, let's come for this one. So when a wave propagates on a rope, then where kinetic energy will be maximum at mean position, where potential is maximum at mean position, where potential and kinetic energy will minimum at extreme point. And we know it's a SHM, no? Will agree. And what happened to a point on a rope will execute SHM. And we know in SHM where kinetic energy will be maximum at mean position, where potential is maximum at extreme point. But here what happened? The things are a little bit different. At mean position only, both potential as well as kinetic energy is maximum. Am I right? SHM spring block, you can take, let me just confuse you rather than making you happy. No, let me confuse you because you must have the comparison also here. In a spring block system, if there's a mean position, so the block will execute SHM. So this will be here maximum velocity, no? And here this will be maximum compression or KE. What is the state of the block here? What is the state of the block? Will be at rest, instantaneous rest. This will be instantaneous rest. So now I'll give one velocity. Kinetic energy will be maximum here. Potential energy will be zero. Am I right? Kinetic energy maximum, potential will be zero. What about here at extreme point? Potential energy will be maximum. Kinetic energy will be zero. So this is at extreme point. Right extreme, left extreme. So what do you have? Okay, this is what normal spring block system. Or most of the SHMs. But now what happened? The points on a rope, they are executing SHM. But here what happened? Both potential energy, kinetic energy are maximum at mean position and both are minimum or zero at extreme point. Sir, how come it be SHM? This is also another type of SHM. Don't say again, it's not an SHM. Are you getting no? This is something I feel very important, student. You should accept this one. If a system executes SHM, then potential energy and kinetic energy both can be maximum at mean position. Maybe, not must be. Because this is one case. What we are discussing is this is one case. Okay, more than an option, so you have to be careful. Okay, no, fine. Okay, finally, what happened? We are in a better position. We are in a better position here. So element 2 is having maximum potential, maximum kinetic energy. Element 1 is having zero kinetic energy, zero potential energy. How do flow of energy will occur? Because that was a point which we are supposed to discuss, no? Sir, how energy flows from one point to another point. Okay, now look at this instant. The energy here is, so look at this particular, the energy here is maximum, no? Potential kinetic, and here it is zero. After some time, because T equal T by 4, this element 2 what happen will have zero energy, and the element 3 what happen will have maximum energy. Means the energy which was present here, now what happen, it will appear here after some time. Don't say it will go there. So no, no, not possible. The energy has to flow in forward direction, in the direction of wave motion. Okay, got this? So the energy which is present here will be given to this element after some time. The energy which is present here will be available for this element. Able to understand this particular thing? And the energy present here will be made available to this element. So energy will flow in forward action. Actually, the energy will flow along the rope. No, not like this. Net flow will be along x-axis here. So at t equals 0, the energy present at element 2 will be made available to element 3 at t equal to t by 4. So better you say that, think like this. The energy will flow here. What happened? This energy, so this sir energy will flow like this. No, it's not like that. The energy which is present here now will come to the element 1. So element 1 is having maximum kinetic energy, maximum potential. What about element 2? Element 2, what happened? Zero potential, zero kinetic energy. So where do the energy of element 2 has gone? Given to element 3. Element 1 was not having energy. How come it got energy now? So this particular element has given energy to this. So like that what happened? There'll be a flow of energy will occur along the length of the rope. I am interested to know this energy. Now tell me, like, if a wave propagates on a string, in what form the energy of a wave will be? In the form of potential and kinetic energy of the rope. Why potential energy? It's very simple. Now you know elasticity. Look at this length. This is some length of the rope. Now look at this length. Where the length of the rope is more, at t equal to 0 or before some time? At t less than 0. What is the length of the rope? Say, like I say, some 1 centimeter. Now look at this length. Definitely this is more than 1 centimeter. You know elasticity. You know elasticity. This length should be more than this length. It is being elongated, no? It's being stretched here. So therefore, now this part of the rope should possess potential energy. And you look at different points, all points are attached here. So what about here? Here they're in moving up. What about this point? They're moving down. So in this way, what we can say that one now, this part of element, what all, this part of the string, what all it is having potential energy, and also it is having kinetic energy. What about here? All points are at rest, and there's no deformation. Here there's a deformation. So when a wave propagates on a string, in what form the wave will possess energy, in what form the energy of a wave will be there on the string, in the form of potential energy of the string and kinetic energy of the string. And what happened, that energy will not be confined to one point. It will flow. It will flow. So this element will give to this element. This element will give to this element. So like that, they'll be in a flow of energy will be there in the forward direction. So what is the conclusion we can make it now? Points, elements which are at extreme will have zero potential, zero kinetic energy. Or instead of minimum, I should write zero here. Got it? And the points which are at mean position, there are maximum potential kinetic energy. What about points between mean and extreme? So when you move from extreme to mean, both potential energy, kinetic energy decreases. Sir, how you can say potential energy? By the slope. You can say this length and this length. Where dx1 dash is equal to dx1 in this diagram. Are you getting no? So I think the best way is what I'm trying to explain. Very simplified one. Student have to just use the basic common sense. Okay, now I'm interested to know that to express that energy of a wave. So whose help I should take? I should take help of the element only. Got that? Anybody having doubt, you can ask me. Anybody having doubt, you can ask me. If you have doubt, okay, you can clarify it. I'll proceed for now the derivation part. Okay, fine. Yeah. We will try to derive and mathematical equations. Okay, that U max, U minimum. Okay, I'll write it. There will be a flow of energy on a rope in the direction of wave propagation. There'll be flow of energy on a rope in the direction of wave propagation. There's a one point. Then the wave energy okay, this one. Yeah, I'll change it. Okay, no? Yeah, thank you. K minimum it should be. I'll change it, yeah. The wave energy will be in the form of this is something this more than an options. No, you need all this particular thing. The kinetic energy of the kinetic energy and potential energy of elements increases as we move from extreme to mean position. Don't say law of conservation of energy. So usually what all the energy is there, that should be what all energy that is present here after some time should come here. So don't say law of conservation of energy anything. What all the energy on the wave, it should remain constant, no, but it will not be confined at one place. It will be propagating. So definitely, but don't say that I'll use law of conservation of mechanical energy. I think it will be a wrong way of asking question itself. Okay, let me go for the derivation part.